outrageously new today. We're just jumping into 5A, and we're just looking at those integration techniques. So chapter 5 is the shortest chapter. It's our shortest unit. It's going to be even shorter than the one you just did. You'll see there's 5A, B, C, D. Today we'll do A, and on Friday we'll do B, and that'll leave us with C and D for week 9. All right, so we'll be looking to test this unit in week 10. Okay, let's get into it. Area under 3x squared from 0 to 1. So if I'm going to graph this function, right, let's just have a little conversation here. You know, if you've got the function x squared, it's going to be the curve like that. Okay, we're pretty familiar with the parabola of x squared. If you have, now this is the function, right, it's y equals x squared. Okay, if you have y equals x squared and y equals 3x squared. These are some of the transformations we've learned in year 11. What's the difference between this function and this one is that it's multiplying it by 3. So that means every y value, rather than being here, is going to be 3 times larger. All right? Here the y value is 0. So 3 times 0 is 0. So that's going to stay where it is. But this one's going to be 3 times higher. And this one's going to be 3 times higher again. And so you can see what happens when we put a number out the front is it's what we call a dilation, is the correct mathematical way to say it. It dilates it further away from the x-axis. It's stretching it. All right, so it's going to have this kind of shape anyway. Like it wouldn't be like that, but we can change our view window so it has a shape like this. 3x squared from 0 to 1. Okay, here's 1. It's saying what is this area? Okay, so the integration techniques we've learned, we're familiar with. The integral from 0 to 1 of 3x squared with regards to x. That's how we're going to solve this problem. The area under 3x squared from 0 to 1, which is going to be x to the 3, it's going to be 3x to the 3 on top of 3. And so 3 at the top and bottom will cancel. It's from 0 to 1. So that would be 1 to the power of 3, 0 to the power of 3, and 1. Okay, area, so units squared. Very good. Okay, so nice easy one. That's what it'll start like, and then they'll get a little bit more complex like this one here. Find k given the area under this function from 1 to k is 4e squared. So first let's make a statement like that. The integral from 1 to k of e to the power of 2x with regards to x, okay, so let's make sure we're getting all that terminology correct. Is equal to 4e squared. Okay, so that's our opening statement, and then we're going to process this and solve for k. Alright, so that's going to be the integral of e to the 2x is 1 on 2 e to the 2x. Let's sub in k and 1, so we're going to have 1 on 2 e to the 2k, take 1 on 2 e to the 1. Alright, and straight away we should be thinking, let's get rid of that fraction, that half out the front. So let's multiply both sides by 2. So here that'll become e to the 2k, take e, equals 8e squared. Where's that? Here. The lower boundary is 1? Oh yeah, 2 times 1. Very good. Very, very, very good.
That's a lollipop.
It's only works solutions. Okay, move the e squared over the other side, so we'll have e to the 2k is 9e squared. Put ln on both sides, so I might write this up here now. We'll come up here, we've got e to the 2k equals 9e squared. Now ln on both sides. Okay, this here is going to simplify to be 2k, and over here we can split that into ln 9 plus ln e squared. Alright, ln a times b is equal to ln of a plus ln of b. I'll pause there. Okay, so we've got the solution, right? And what I'm going to do now is just fiddle with it a bit until it looks nice. So that's going to be ln 9 plus 2. And we move the half over the other side, or move the 2 over the other side. We'll have k is going to be half ln 9 plus 1. the log law again. If the number's out the front, it can become the power there. So we'll have lim 3 plus 1. We should write it like this. Now the reason we should write it like this is just to be really clear that it's the natural logarithm of this number, and then we've got 1 added on at the end. What a beautiful answer. Okay, so any questions about that one there? No, awesome. So let's get into 5a.